Dylan, how are you doing today?
I'm doing well. Holidays were relaxing. Getting back into doing real work now that we're into the new year.
Brand new year. It feels the same as it did last year.
There's always that challenge of everyone else took off for the holidays, and I'm the new guy, only 2 months in, so
You got stuck there. You're like,
yeah.
gotta be here.
There's lots of free time to do random things because I don't have anyone to consult with because they're all out on vacation.
I love the time when everyone else is out on vacation. Like that last week before Christmas, I got so much done. It was, I don't know, it was like meditative. It was great. No one bothering you,
The productivity.
knocking stuff out.
Productivity. Matt, how are you doing?
Good. Holidays are great. I also have been at my new job for about almost 2 months, and I also felt weird taking time off, but I saw most people were out, and I just kind of copied their out of office schedule, and I was like, I guess I'm out too. So it was good. It was a good time.
That's good. Yeah. Ian, you've been at the same job a while. So
Yeah,
how
5 years now.
How are you doing?
I'm doing great.
You know, you're not the new guy,
Well,
so.
Yeah, not the new guy. I still didn't take much time off. But like I said, I love that pre-holiday time where no one's bothering you. Did hurt my back over the break, so I'm recovering from that. Not great, but we do what we can.
Yeah. Yeah, it's been an interesting few weeks getting into this new year. It snowed on Christmas for the first time in a while in New York. I was like, oh.
It was nice.
And then
It was
there was
pleasant.
a crazy thunderstorm on New Year's Eve
Less
in New
pleasant.
York. And I was like, oh, those poor people in Times Square. Also, the fact you're in Times Square is just annoying. So
My dog is terrified of fireworks, but not bothered by thunder at all. And so it started like thunderstorming, and he just thought everything was thunder after that, and was not nervous at all. It was great.
yeah,
It should thunderstorm every New Year.
the random fireworks in the street, too much.
Oh, they were going until like 2:20 in the morning by me, and I was like, "What are we doing?"
We didn't quite make that.
20 minutes
they went
after the New
till-
Year, fine. 2 hours? No.
Yeah, they went till about 1:30 here. No, I've also reached the age where we don't go out and party, so I spent New Year's Eve on my sofa with my dog under my feet, cowering in fear from Armageddon happening outside.
Y'all should have had a thunderstorm. It would have solved everything.
Yeah. No, I definitely stayed home because, my friends were like, oh, you're not going to go out? And I'm like, no, too much proximity to Midtown. I don't want to be out and have to go to near a train station that is in or around Times Square. Just no, thank you.
Yeah, that doesn't sound fun.
I'm good. Maybe if I lived in another borough, I'd be fine. If I lived uptown, but no, for being in Manhattan night, I'm like, nah, I'm gonna stay inside. Unless I had a party at my place and got more drunk or something like that, then maybe I'd be out and about. But I was just like, nah, I'm just gonna sit here, just ring in the new year, chilling on my couch. It was nice. All right, so on today's episode, we are talking about whether we think you should code. And this is part one of a 2-part miniseries. I guess 2-part. Is it really a miniseries if it's only 2 episodes?
Maybe it's just
We
the
will
first
have a
half.
follow-up.
It's a
It's the
duology.
first half. Yeah, it's the first half.
It's a dual 2-part episode, I guess. 2 episode series. We'll call it 2-episode series. That's what we'll
First
go with.
act.
First act of a 2-act podcast episode thing. Yes. Naming. One of those tough things in our industry. So, yeah. Anyway, this is part 1 of 2 parts where we're going to be talking about coding and careers in coding and all of that. And in this episode, we're going to be talking about, do we think you should code? Or do we think you should learn to code? If you know how to code, you should probably code. Do we think you should learn how to code? And before we jump into that, we're going to talk about why we decided to learn how to code. So who wants to go first? Who wants to tell their little short story about why they learned to code?
I feel like you never go first, so maybe you should go first.
That's
I'm a
true,
host.
Chris.
I
Put you in the seat.
Sure, fine. Okay.
You're always so kind. You're like, you let the round robin go, and you're always the last one, so we can start with you.
That's what proper hosts do.
Yeah.
Okay. So yeah, I come from a household of programmers. My mom was a programmer for a decade. My dad is, to this day, a software engineer, low-level software engineer. So I kind of grew up with the kind of ethos of like lots of computers, lots of tech going on in my house. So I first learned to code when I was 13, I want to say. That's when I got my first programming book. And I took, permanent courses in high school, never really got any of it. So I was like, I'm not going to do this. And then when I was in college, we had this thing where I need to build a website. And I was like, you know what? I think I have enough skills to build a website. So I learned how to build a website. And I'm like, this is fun. And I kept doing it and kept doing it and kept doing it. And then I went to graduate and I was like, I have career opportunities. And I was like, I think I want to learn how to code. I think I want to be a programmer. Let's try this out. And I sat down and I learned how to actually write PHP instead of just clobbering together random snippets of code I found on the internet. And I just kind of kept going from there. I never really stopped from that point. So I think the decision was mostly like, I need a job and I need a career. And I felt like programming, software engineering was the career that at the moment felt like the best fit for me. So that's why I learned to program.
I had no idea that both your parents were programmers.
Yeah.
That's awesome.
Yeah. I come from a programmer, from a computing lineage, I guess. I have like some aunts and uncles that were also computer people. So
Wow.
Yeah, I think
that's cool.
I think I come from the opposite end of that. My dad was a school bus mechanic, and my mom was a school bus driver. There was, yeah. I don't know where to go from there, but I learned to code first because I thought I wanted to be like a designer, maybe like a front end developer. So I learned HTML and CSS, and I don't know, probably like 13 or 14, started put together websites. At one point I had my own like e-commerce store that I used to pay for college, which was pretty cool. But I did find out I was a garbage designer, but I was pretty good at the coding part. And I just found it a lot of fun. Picked up a PHP book at a garage sale and kind of went from there. And then I got to college and I did not want to do software engineering as a job. It was like one of my favorite things to do. So I kind of wanted to keep it as a hobby, right? Like I had that naive idea that if I made it a career, I would not like it anymore. And so far that hasn't happened, so I'm good. But so I went to school for math, and just ended up falling into a computer science internship and just haven't looked back. Like I finally got into doing it professionally and it was a blast and I just haven't stopped since.
So we both kind of fell into it.
So
Yeah, I never had a dream to be a software engineer or anything. But I do love it, so.
I guess I also sort of fell into it. First learned to code in middle school. We had a program where they called it the Talented and Gifted program. It replaced our English class, and we got to do advanced grammar, but because we were skipping ahead, we also got to play around with art and music and computers. So I got to play on a Radio Shack TRS-80 in middle school writing BASIC. Took Pascal in high school and actually went to college for mechanical engineering. I was convinced I was going to be a rocket scientist and build spaceships for NASA. Fast forward 3.5 years and several D's and drops in thermodynamics and fluid dynamics, and I needed to do something else. And for about a year before then, I had been working as a lab monitor in the petroleum engineering department at LSU, basically helping people come and figure out why they can't print their Word document. But they were doing a project across the hall, and they needed some help coding, and I was capable because I'd always done it as kind of a background hobby. So when I needed to change majors, I was like, oh, I should give this computer science thing a whirl. And 3 semesters later, I graduated with a computer science degree. Started off fixing Y2K bugs, and spent a long time in healthcare and various other places, and here I am. So I was never big on the hobby project side of it. Past being a teenager, so it's always been a professional thing, but at the same time, it's always fun to learn the new things and keep up with the industry and find new problems to solve.
I think that puts it on to me then. I much like Ian, I kind of didn't have parents for that, right? Like opposite of Kris, my parents were as far away from technology as you can possibly imagine. In fact, only one of them actually graduated high school, and so like my siblings and I were the first like generation of college kids in our family, which is cool. But I had no idea what I wanted to do heading into college, right? Like growing up, we got our first computer was like some Dell or Gateway maybe running like XP or something. And I was like, I don't know what this is. You can use AOL. Great. Okay. So I can just chat with my friends on AOL. That's all I really did with it. And then as it came time for college, I was like, what should I do? And this was around the time when Iron Man was like coming out, right? And I was like, oh, I'll be a mechanical engineer. I'll be Iron Man. Right? That's what I'm going to do. And my friend convinced me to play video games on a computer. He's like, hey, you should build a computer, go to Micro Center and build a computer and play games. And I was like, you can do that? You can actually play games on the computer? No way. And that's kind of what got me using computers more. And information technology was like the hot word of the time. Like, you can get a degree in IT and you can make money and da-da-da. So I was like, oh, I guess I can do that. And I went to college for IT. And what brought me to like coding was I hated my coding class in college. I hated it. I was like, Java, what is this? Like system out print line, what? No. Public static void main. No. I'm good. But as I like got into the industry and used more like computers, I started to realize like, oh, there's layers to this stuff. And the things that I'm using to do my job are written in programming languages. Like it's software under the hood. So if I wanted to get better, I should learn what's underneath. And that's how I kind of went into the coding aspect.
Yeah, I do. It's one of the things that always strikes me how separate like the IT side of things from the software engineering side of things is. Yeah. Because like, I mean, like, I guess I kind of just popped in my head that not only were both my parents software people, they met in college studying computer science. Like that's what they were both studying.
That's awesome.
But also my dad, from a very young age, was just like, yeah, this degree doesn't mean anything anymore, so don't get one. Like, there's no point. You're not teaching things you actually need. So it was never in my brain to ever go get a CS degree. But I do remember being young and going to computer fairs with my dad and buying all the parts and things you need to build computers. So I was always super savvy with building computers and always having multiple computers, which I think people in their minds usually equate these two things together. They're like, oh, if you're a software person, then you must be really good at computers. And I remember I guess this was a while ago now, at one of my previous jobs, where it's a whole bunch of very smart software engineers. People that are very competent in building things. And one of them wanted to upgrade their SSD in their computer. They wanted more space for something. I wanted a faster drive. I don't remember what it was. But I was talking to the IT guy. He's like, oh, yeah, I brought it over to this person. And I handed it to them. And they just looked at me. And I was like, and the guy was like, oh, do you want me to install this for you? And they were like, yes, please. Because they didn't know how to put a hard drive in a computer, which is like something that didn't really occur to me like prior to that like just because you can build software doesn't mean you know how computers work or how to put one together or anything like that. I mean,
Kris, you work on computers. Can you come and fix my printer?
Well, I mean, there's that too. And it's like, I mean,
my smartphone's acting up, please.
No one can fix your printer. It's a demon machine, and we keep them in dark places for reasons because we don't want them to, you're worried about AI. We're all worried about our printers and what they might do.
Oh, yeah.
I do work with computers. I do not work on computers.
Yeah.
Yes, but I think that's like an important thing, listener. If you're like, oh man, I'm sort of interested in like maybe doing some coding or anything, but I don't know how to like put a computer together. I don't know what a hard drive is. Like you don't really need to know that stuff to get started. Like if you can't build your own custom PC, you're fine. You can learn to code. You don't need to know that stuff to be able to code. And that's a super important thing.
Interestingly, when I started college, I was just ahead of the wave where all of computer science shifted to Java and Python. So I learned to code in college in C.
Nice.
Yes.
I wish I would have learned C instead of Java.
That would have been probably more interesting because I like to be
100%.
closer to what's happening.
You definitely, and even then, C was tricky to learn. Once second year, I took assembly. Like for loops and pointer arithmetic became very easy once you can write it in assembler.
Yeah.
Like, okay, now I understand what the machine is doing. So it's no longer tricky to figure out what this nasty expression with parentheses and stars and ampersands is doing.
Perhaps they didn't offer it on my degree track because I took an IT degree in college rather than a CS degree because that was the term that I was hearing more. I didn't know computer science, like what it really was at that time. But the IT degree covered zero assembly. It was just like Java. And there was like a MATLAB course because some reason, but it just was Java. And I was like, looking back, I'm like, we didn't really touch how this stuff actually works under the hood.
I saw Java in the history of computer languages class, but all of my coursework was in C and x86 assembler and C++.
Yeah. I want to go back to the point Kris was getting at where you don't need to know how to build a computer or whatnot to code, right? And it's true. And I've seen this, this maps pretty well to other professions too, right? You don't really need to know how the car is perfectly built or whatever to be a good race car driver. You really don't. You just have to be a good race car driver and train for that. It doesn't matter if you can take apart the engine or change tires or whatever. That doesn't matter. You can suck at that as long as you're a good race car driver. And similar in coding, like you don't have to know exactly how the hardware and everything works under the hood. It can help you obviously be better and be more efficient, but it's not like a hard requirement where it's like, I couldn't put RAM in RAM slot. I'm a failure. It's like, no, you're not a failure. Okay. It's okay. I swear.
It's like USB plugs. Turn it around. It still doesn't work. Turn it around again, and now it'll be fine.
Yeah. Although the new version of that is, what does this USB cable I have support? Does it do charging? Does it do fast charging? Does it, what's it gonna, is it a Thunderbolt cable? Is it not like what?
You're so not wrong. I literally had to buy a specific Thunderbolt 4 cable for this device I had. And I was like, I went down the rabbit hole of standards and I was like, why? Okay. Never mind. Purchase.
The non-universal serial bus.
You're like, oh, why does this thing cost $70? And then you like actually look at the tech inside. You're like, oh.
It's really impressive. It's hard from a consumer side to understand like what cable's doing what. The marketing's not the greatest.
I feel like that's quite a bit like how like different programming languages and things of like what is this language supposed to be used for? How is this supposed to work? And I feel like that's like so much of the time people want to pigeonhole like, like I guess like I'm trying to say like in the old days, right? You had like specific cables that you use for specific things, and you had specific programming language used for specific things. Like you use Java for one thing, and you'd use maybe Objective C for another, and C for another, and C++ for another. And I feel like all of that has now gone away. And now it's just like all of these languages can pretty much do everything every other language can do. And I feel like that causes a lot of confusion for people that do like want to learn how to code or want to get into this industry. They're like,
do you mean confusion of like where to begin?
Yeah, like where to begin, or even like I feel like it's easy to get nerd sniped into like language wars. Like language wars have always been around, but like I mean, you're not going to build an operating system in PHP, right? So it's like there were things that was just like, no, of course you're not going to use this tool for that. So I feel like the breadth of nerd snipey things was much smaller. You know, like
Yeah,
back in the day, it was like Vim and Emacs, and that was
I
just like,
still see a lot of I'm new to I'm new to this, looking to get into a career in programming. What's the best way to learn Go or Rust or whatever the thing may be? And kind of to your point, maybe that's not the best thing at all. Don't go into it thinking I want to learn language X. It's more I want to solve a problem. And
yeah,
that's usually the advice is the best way to learn whatever language you're diving into is to go think of a problem you have that you know how to solve and go solve it with that language.
yeah. Or probably maybe you don't know how to solve, and then go figure out, you know,
Yeah, or
what do I need to
explore the
solve?
space
Yeah,
in that language, and you'll learn it as a side effect rather than going in with the idea of I'm going to go learn Go.
Yeah. Counterpoint to that though, like say I'm just getting started in software and I'm like, I don't even know if I like programming yet. You know, I'm trying to learn. And if I pick up Rust, I'm probably gonna hate programming, right? Um,
Or you're gonna
so
love it.
No.
Rust as your first language seems difficult. Maybe I'm wrong, right? It, but picking up something like even like Java might make more sense, right?
Yeah, I feel like Rust is not a great gateway drug.
But I feel like there are a decent amount. Like, say you pick up Java and you're trying to solve a problem and you hate it. Do you think switching to Go or PHP is gonna change that, or like is giving one a solid go enough to decide if you like
Uh,
programming or not?
Maybe not, because there are some drastically different paradigms as well. Like solving a problem in Go is a vastly different exercise than solving the same problem in a dynamic language like Python or JavaScript.
I mean, for me, right, if I look at my own journey of how I became a software person, um, what I learned to program when I was younger, like my first programming book was like a programming for dummies, and I taught you QBasic. So I like did that, and I was just like, oh, this is cool. You can make the computer do things. And then I was like, then I just kind of lost interest in it. And then in high school, I learned C and C++, and I was really good at writing those things, but my brain was just like, I don't know what you use this for. I don't know how you like what applicability does this have to anything I'm trying to do. And I like messed around a little bit with Visual Basic and all of that, but it wasn't until like I had a thing that I needed to do when I was like, I got to build a website. Or I think like the very first website I built was there was this whole thing we did at the TV station on campus where we'd have like these movies. We do this thing called Movie Marathon. People would vote. And I built a little web app to allow people to vote online. And I just kind of cobbled that together with a bunch of PHP. And I was like, okay, this is cool. I like this. And it was these steps of me like solving problems that were important to me that I was like, oh, this is interesting. And then even more to that point, like the first time I tried to pick up Go was like super early in my career. And I was just kind of like, I don't understand this. Like, I don't understand what this is. This syntax looks weird to me. What is this colon equals thing? This makes no sense. And I like put it immediately back down and went back to PHP. And it wasn't until I had a problem that Go fit more of like my desire to have more simplicity instead of so much complexity that I was able to pick Go back up and be like, oh no, this is beautiful. This is exactly what I wanted. So I think, especially when it comes to programming languages, you need to have a problem you're trying to solve before you try and learn the language. I think if you just try and learn the thing, you're going to have a much rougher time than if you have a specific thing you're trying to do. And I think you should have multiple things over time. I don't think it should just be one thing. But I think that's like a very good way to make sure that you're going to be able to like guide yourself properly.
Funny you mentioned colon equals, because that for me that was a throwback to learning Turbo Pascal in high school, where you also had allocate and assign via colon equals.
Kris, I kind of think your point leads well into something I've been thinking about, which is like you're saying you need to have that problem to solve with the programming language you're learning. But like to me, the programming language is the tool, not the skill, right? Like you don't if you want to get good at digging holes, you don't learn shovel, right? you that's the worst example I've ever made, you know. But
No,
like,
that's a great example.
That's a
It is
great
very
Especially with the
apropos.
internet memes of like, be the one selling shovels. That's spot on.
oh, so yeah, the question, should you learn to program, isn't the one. It's like, do you want to solve problems? Should you learn this tool to solve problems, right?
Yeah.
Um,
But I think that, you know, there, in that analogy you made, I think there's a little hidden thing of like, yeah, you're trying to learn how to dig holes. And it's like, okay, shovel is good for small holes. But if I want to make a big hole, then I need like a backhoe. So I should probably like maybe sometimes need a shovel, sometimes I need a backhoe, sometimes I need a, you know, a drill of some sort, right? It's like, what type of thing am I trying to do? And you learn this collection of tools you can put in a toolbox, and then you can use those. And I think that's the same thing in programming or in coding or software building in general. It's like, don't just learn a tool for a type of problem you're trying to solve, and then you'll also be able to find other tools that will help you actually solve that problem at different levels.
I've always had this mental image. First 2 summers out of high school, I worked framing houses as a carpenter and did some amateur woodworking for the next few years. And I kind of have this mental image of woodworking jigs. It's like, I'm trying to make a thing. And you have all these various power tools, but you also have these various jigs and setups and things that you put together. And it's like, oh, here's how you make a door. You use this thing and you cut it this way, and then you put it over here and you use the router to round over the edge. And it's assembling all these different tools and other pieces that you've built over the years and have in your toolbox to go make a thing. And the toolbox is the language, the libraries that you've learned. That's kind of like Ian said, it's beside the actual problem of I'm trying to do a thing.
Yeah.
yeah, it's funny you say that. As a hobbyist woodworker, I think programming and working are super analogous, because it's like, it's not just, oh, I need to use this saw to make this cut. I need to make this tool to make this saw that can cut a straight line. It's like the same type of thinking. I'm
Yes.
trying to think of a good way to describe that. But if
No, I
you
mean,
like
it's
that type
true.
of thinking, you should learn to code, because you can put it on. I don't know.
There are definitely a lot of parallels and a lot of similar mental pathways.
I feel like
Yeah.
there's a lot of people that do programming that wind up doing woodworking as like a fun side hobby. Like, oh, I actually want to work with my hands. And then you just, wind up doing woodworking. Or
And it ends up
something in
being
that scene.
it really does end up being like the same type of thinking. It's like process, like order of operation, like what do I need to cut first? You know, you have to, like,
If
that
you-
same creative mind mapping that you do when you program, you have to do for woodworking.
If you ever made a template to like make successive cuts in woodworking, congratulations, you've just made a library.
You are learning to code.
Yeah. Congratulations. Check.
You're already on the path.
Yeah. And to answer the question you asked way earlier, Ian, about is one language enough to like know if you want to code? I personally say no, because like if it was up to me and I just stuck with Java, I didn't like it, right? And that turned me off. But I tried other languages, right? I tried C, I looked at Python. I even looked at Scratch for a little bit, because I was like looking at, okay, what's this logic for me? And that kind of got me back into it. And that's what kind of jump started me. So if I gave up just at Java, I probably wouldn't be here today, right? I wouldn't like here in this podcast doing this thing, because I wouldn't be in software probably.
Yeah, I think it's
To
like,
me, it was never a language that drew me into software. It was always that like problem solving. Like a lot of the early stuff, like something I did early was make Yahoo Messenger skins, right? And it's like that. It's always like that same type of thinking. There's like, how do I make this happen? How do I solve these problems? And yeah, I love Go, but I kind of enjoy programming in whatever language I have to, right? I've
Same.
been doing a lot of like Python and like Apache Spark, and even that like scratches that same itch, right? So to me, if you have that itch, all right, you should learn to program.
I think my first kind of carrot of, ooh, this is really cool, was doing turtle graphics in Logo. Way back when, like go
Yeah, you're gonna have
forward
to
100.
explain
So
both of those things for
turtle
or at least
graphics.
me.
Turtle graphics is the idea you have this little cursor and you move it around the screen and it draws a line as it moves. And Logo was this logic language, but it would amount to move forward 80 units, turn right 25 degrees, move forward this many units, turn left this many degrees, and you kind of wait. I can write this code and out pops a flower. At the time I was in middle school, like 10, 11 years old. So like this was an amazing thing. Wow, I can make the
coolest spirograph
computer.
ever.
Yes, I can make the computer do things. We did spirographs. Like, what happens if I just move forward and then right turn 1 degree forever? Because it would just cycle around the screen and you would get these various patterns popping out. And it was like, that was a cool thing. What else can I make it do?
That's kind of similar to my ideas, is the curiosity. Like, what else is there, or what's behind this? Like, what more is there? That's what drove me. I didn't always have a problem to solve that led me to software, but I did have a curiosity. I was like, how the heck is this doing the thing that it's doing? And I've used that perspective to like dive into software.
I feel like that's the thing. It's like, I think a lot of people often ask me, like, how did you like ascend to like, in such a short period of time to like a high level within like in the engineering field? Because I don't know, not a lot of people become.
How are
like,
you God tier, Kris? What did you do?
How did you become a principal engineer before 30? It's like, I just have this like need to understand how things work, and I would just dig into things until I found the answer. And the interesting thing that happens with that is when you dig into things very deeply, you end up learning how like so much more actually works. So then when it comes time, when there's a problem, and it's like, oh yeah, that's not how that thing works. This thing looks like XYZ, and you can explain it to everybody because you just found it on your path traversing through a bunch of other stuff. And then everybody in the room's just like, oh, well, you know way more than anybody else here. Like that's crazy. But it comes from that like that curiosity and that need to understand.
I think it's both the curiosity, at least for me, it's that same curiosity you're talking about, but also like this almost clinical drive to not stop until I find that thing that I'm looking for, right? Like
Guilty.
Yeah, no, that's the little
and, like,
obsessive brain.
Yes.
But that has served me very well, because like you're saying, it's like, your team's handed this project that has this one little thing you need to fix, and you end up doing a deep dive into it, and all of a sudden you know everything about it, and everyone's like, how do you know how all of this works? And it's like, well, there was that one thing wrong, and I couldn't stop until I knew everything. So
well, I pulled the thread and it fell over, so then I had to put it back together.
Yeah, computers, they're just going to do what they're told to do. And at some point down the stack, something is responsible for making this thing do whatever it's doing. And I'm going to find it.
I can't even count the number of times I've used that quote where somebody's like, how did you figure this out? It's like, well, computers are dumb. They do exactly what you tell them to do. So if there's a problem, it's not because your computer's broken. It's because there's some instruction that you gave it somewhere that it interpreted literally and then went off on a tangent and did the wrong thing. So the kind of to reiterate the curiosity thing, it's where is the thing that I put in wrong? How do I follow the thread to find the thing that caused it to go off the rails?
I want to answer the question, do we think we should learn to code? But before we actually answer that question, we've been talking about like learn to program, learn to code, languages, this, problems, curiosity. What do y'all mean when you say learn to code? Like learn a language to hello world? Check? Or like what do we mean when we say this?
Even better, what do we mean by the word code? But
that's fair.
When I see should you learn to code, my mind immediately goes to like, should I make a career in software engineering, right? I don't think it's just like, oh, I can dabble with JavaScript, right? Which I think kind of anyone should be able to dabble with JavaScript and like mess around with things. But I don't think that's what it means to learn to code. I think learning to code is kind of deeper than that.
Yeah.
And maybe that's a perspective maybe that's a perspective y'all don't share, but
maybe I'm showing my curmudgeonness a bit, but I always got an ick from the idea of learn C++ in 21 days or like the crash course. It's like, no, there's much more to it than that. So learning to code is, to me, learn to code has always had this connotation of kind of similar to what you said, Ian, where it's like, hey, you take this crash course and you too can be a software engineer. So it's always kind of rubbed me the wrong way because it's like there's much more to it than just learning to code.
Yeah, I mean, of course, this is going to be my answer, but I kind of see, the word code there in the same way that I see the word writing or that I see math, right? Should you learn to write? Should you learn math? I think the answer to that is obviously yes. Like, do I think everybody should be able to write? Like, yeah, you should be able to, like, put together an email or, like, write a tweet. Like, I think you should be able to do these things. You should be able to do basic arithmetic and, maybe calculate tax and something like that. Like, I think people should be able to do these things. Should you do it professionally? I think even that has a lot of nuance to it. It's like, what do we mean professionally, right? I think the vast majority of people in this world that are programmers are people that can put together Excel spreadsheets, because that is programming. Like, if you sit down and watch people build spreadsheets, that is absolutely programming. And it's like, do I think you should be able to do Excel professionally? I'd be like, absolutely. I think spreadsheets are extremely helpful in basically every industry, in pretty much every job, unless it's like very, very, like, I go into a factory, I do a thing, I go home at the end of the day. If your job isn't that type of thing, I think, yeah, Excel spreadsheets are going to be very helpful for you. So I think there's like levels of it, but it's like, do I think everybody should be a professional software developer? Like, do I think it should be your job to build software for other people? I think probably not. But I think that's like much higher on the level of things for me. I think there's like different tiers. I think the lower two tiers are like, yes. And I think all of that is learning to code at the end of the day.
Yeah, you bring up the Excel thing. Like, I think learning how to program in Excel is probably like, as far as like the learning to code ethos, that's probably the single easiest thing you can do and get the most bang for your buck, right?
Well, I don't know about easy, but
it's easier than learning a language, but you still get a lot of that functionality. You still start learning how to think in the way, like that very structured way. Like, yeah, I would say learning Excel is learning to code in the non-career way.
As far as ROI, learning Excel is probably your biggest bang for the buck also, because even if you're in something very super artistic, like you do abstract art, you still can use Excel to go do invoices and, like you said, track your bills, track your spending, project how much money are you going to have after 6 months. And those things are still coding in a sense that, like Ian said, you're learning to break down a larger problem and do calculations and assemble parts together. And so you're coding in a sense without actually, compared to learning Rust or learning x86 assembler. Those are different animals. Both are coding. So I guess I'll concede, yes, you should learn to code, in that you should learn enough to be able to do your monthly bills in a spreadsheet if that's something that's convenient to you.
I feel like I want to push back on the idea that like Excel is easier than other programming languages. I think Excel is hard, right? I think it's because
I wouldn't call it easier. I would call it more accessible.
I think the barrier to entry is lower.
Yeah, I think because it's like, if you look at there's a whole, like, people give talks, and I think there's even competitions about the ridiculous things you can do with Excel, like the ridiculous things you can model and build and create, and you're like, how can you even do that? That doesn't make any sense. So yeah, there's a lot of magic in declarative programming that I absolutely love. But I think I specifically want to say that Excel is harder than programming languages, because I think that framing it that way makes other programming languages more accessible to people, right? Like, I think imperative programming languages are easy for a lot of people to understand how they work because it's just like, oh, does this thing, then 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 this thing. Whereas Excel, you know, you have this giant declarative space, and you enter something in one cell, it could affect cells literally anywhere else instantaneously in your spreadsheet, and that models a way of thinking that I think is very helpful for, say, you know, distributed systems thinking, or even like large systems thinking, that I think like learning a imperative programming language probably doesn't give you. So I just want to like kind of push that idea down a little bit more to people that are considering doing this, of like, if you're really good at Excel, you're probably going to be really good at building software in general. And don't be discouraged because you're like, oh, it's just Excel. It's not something that's like that important or that hard. It's like, no, it is hard. There's a lot of good skills you learn in how to build a good spreadsheet and how to model and make a good spreadsheet that are applicable to the rest of software development. So like hard and easy are probably not the ways to quantify it, but I would say,
I guess
like,
what I
don't
was
discount
thinking.
yourself.
I guess what I was thinking is, you can do things in Excel that have practical value with less effort than to go and learn Rust or C++. Like, you have to invest a lot more time to get something concrete and practical out of it.
Yeah, I would say like, if like I think the people that should learn to code, like, do I think people should learn to code? I'm like, if there's problems in your life that you're trying to solve and you can figure out how to solve them with code, then yes, please go learn to code. Because like, I was even doing some stuff with Excel, or the annoying, almost like Excel numbers. Like, numbers is just, I need to actually get Excel because numbers is driving me crazy.
Mac users
makes me upset.
outing themselves already. No,
I need Excel so bad. But anyway, I was doing a whole bunch of stuff, and just the amount of things you can get in a CSV format is just truly crazy, right? You can go to like I got all of my Uber Eats orders in a CSV. I got all of my Amazon orders in a CSV. And then you can take that CSV and dump it into Excel, and then you can go do a whole bunch of other stuff to like pull that information and put in other things and then display and aggregate and do all this. That just made the thing I was doing so much easier than if I had to like look at some web interface or something like that.
Large portions of
or
society,
create the web interface.
very large segments of society operate by exchanging comma or pipe or tab delimited text files.
Yeah. And then also there was a point too where I just was like, oh no, like this date format isn't right, and it's like making like numbers barf for some reason, or like, oh, this, or I kept getting this thing where like the records are in the wrong order, and I was like, how do I reverse this? I was like looking for some function inside of numbers, I couldn't find one, and I'm like, wait a minute, this is a CSV. So I just wrote a 30-line Go program that brought in the whole CSV, flipped the slice around, and spit it back out, and it was done. Or I went in that, like, sucked it in, looked at the date, and spit it out as another format, another column, and spit it back out. And I'm like, oh, combining these little tools together, like writing a little bit of Go and having numbers, and I got exactly what I wanted at the end of the day.
That to me is the learn to code. So like, to give my answer to learn to code thing definition, when I see should you learn to code, I read learn to code as should you learn how to configure the computer to do things. And then from there, that's like the start. And then from there, it's should you do that with some, like Excel or some graphical thing, or should you learn like more powerful programming languages and be like a software engineer to make software? That's where it diverges. But for me, the very basic is, can you configure the computer to do something? And Excel spreadsheets and CSV like files are hugely important. And I think it's a great starting point for anyone. For meetup.com, they export you can export their the attendees for your meetup as CSV. And then every building that we have to host meetups at, they want their own specific CSV format for guests. Great. Export, write Go, switch it up, import it somewhere else, done. That's coding, right? Like, but that's not software engineering. That's not like creating software, but that's coding, and that's a valuable skill. And like go do that manually, and it'll take forever.
I thought I was the dinosaur in the group, and you guys are talking about exchanging CSVs instead of JSON files.
Oh, that's because JSON is terrible.
I have a
It's the new hotness.
So I have a friend that does R&D for he makes like the lighters for grills, basically, right? The things that light the gas, and there's a bunch of, during R&D, they do a bunch of measurements and stuff, and every once in a while he'll call me and be like, hey, I have this set of measurements and I need to make this transform in Excel and I can't figure out how, right? He should learn to code. He should not be a software engineer. He should learn to code.
Right.
right? So in that regard, I think a lot of people should learn to code, but maybe not everyone should make it their career.
Yeah, totally agree with that. Like there's so many professions out there that learning to code can aid you in your profession, but you're not software engineering, right? Like you said with your friend there, or even my wife, like she's a chocolatier and she knows nothing about computers or whatever, but she's had to learn how to use Excel and code up formulas and do her budgeting and her accounting and also social media. She has to learn how to like automate some of those processes. That's not strictly software engineering skills or programming languages, but she's coding. She's telling the system what to do for her to make her business better. And like that, for me, when I read, should you learn to code, that I'm always going to answer yes from that perspective. Then the secondary question, should you be a software engineer? I'm more on the I don't know, maybe. It depends. That's where I lean that way.
If you interpret code literally, as in take some information and encode it into some structured format so that you can do something with it, then yes, everyone should learn to code. You should invest effort into learning how to break down a complex problem into parts and organize them in a way that you can get to the next step in whatever it is that you're trying to do. And very often, using a computer to do that is the best thing, the best step. And they're prevalent. At this point, everything is a computer. You have more computer in your pocket today than flew to the moon in Apollo 13.
Allegedly flew to. I'm just kidding. Come on, you gotta have a little bit of fun.
I mean,
or I mean, the Voyager interstellar spacecraft is running a few hundred bytes of code, and we have gigabyte hard drives on our phones in our pockets. So learning to code is kind of part of society these days. Everyone needs to learn how to code to some extent, but I'll definitely agree that should you take it to the next step and do it professionally, do it full time, become a software engineer, that's a different bar.
Yeah. I also think if you do want to become a professional software engineer, I think one of the things that I definitely experienced a lot when I was early in my career is I talked to my friends who, like, not most of them were not like computer people. They weren't doing software. They were just doing other things. And they'd be like, oh man, that sounds like a lot of math you got to do. And at first I would say there's like no math needed. But then I'd realize in my mind, I had made the same mistake that lots of people do, where it's like, yes, coding and software engineering is very math heavy, but it is very discrete math heavy, not continuous math heavy. So it's not a lot of like, you don't need to know calculus or any of that. You need to know like the logic side of math in order to do programming.
Algebra.
Which I think
you need algebra.
Well, yeah, you just need algebra. But I don't think people understand like what algebra is, like a very interesting like subject, because SQL is also an algebra, and there's like that. But anyway, I don't want to get off topic. You need some algebra, right? You need some basic arithmetic. You need logic. You need some, all of that. But it's not like there's not giant formulas that you're writing at the end of the day. But I also think it's important to understand like all of those movies that everybody watches that are like, oh, the hacker. Or I remember I saw this one like clip, and he's just like, I know one language, and it's 10101, and I'm like, absolutely not. Like, no, that's not. You are incorrect when people say like, oh, all computers understand is ones and zeros, and I'm like, A, that's not correct. Computers don't understand anything. That's not how computers work. But B, saying that computers or like programming or coding or any of this is about ones and zeros is kind of like saying writing is about the 26 letters of the alphabet. It's like that's how we encode the information. Yeah. That's like the very base level thing that we're doing. But like that's not the breadth of it. And you don't need to understand like how did we get this alphabet, or how does the alphabet work to be able to be a good writer. And you don't need to know how binary works to be a good programmer or a good software engineer.
I mean, I even have the t-shirt. There are 1-0 types of people, those who understand binary and those who don't.
I think that's where we get like the gatekeeping coming from, Kris, not from the t-shirt, from what Kris was getting at. That's where I think we get the gatekeeping from. It's like, oh, if you don't know how the CPU works or how binary this, you're not a programmer, you're not anything. It's like, well, no, there's so many layers to this that you can make coding and software engineering your career and not have to go low level or not have to go high level. There's these niches that you can fill that are there in life that you can do this as a professional like career. That's not strictly like, oh, I'm writing software every day. Like you can just update themes for people, and that's coding as a hobby, or that's coding as a profession too. You can do that all day, and there's need, and you can probably never run out of work. The same way a general contractor comes around to like replace your toilet or something, or like some plumber comes around to replace your toilet or something. Same idea. That can keep you employed, and you can make a career out of that. Will it be like the most deep, fruitful career or whatever, like with protection against layoffs and stuff? Probably not, but you can do it. And I think people have this in their mind where they're like, oh, if I'm going to be a software engineer, I have to be the principal engineer before 30 if I'm going to do this. It's like, no, you don't. The same way you don't have to be LeBron James playing basketball, or the same way you don't have to be a CEO of a company. Like you can be in the general average, honestly. Like you really can. There's so much room there.
As a bit of a counterpoint, I will say, having gone through university education and I have a CS degree and learning how the machine works, actually understanding the lower level bits does make me a better software engineer.
Oh, of course it does, right? But that doesn't mean every job in software is that.
I think like you don't need to know that when you start, but eventually you should learn that. Right, like I think there's some people that might be like, Kris, aren't you the one that said that like everybody should know what a cache line is? And I'm like, yes, eventually you should be able to understand what a cache line is. And in fact, early in your career, you should be able to understand it. Part of the problem is that there's not enough good material to teach you what cache lines are and why they are important and like how CPUs work. Like I think Ben Eater on YouTube has done a great job. Like if you're ever bored one day and you want to nerd out to some content about like how does a computer work, Ben Eater has fantastic content on that. But I do think people like eventually you need to learn these things. But in the beginning, like no, just learn how to solve problems. Solving problems is the important part. Solving problems efficiently is the thing you can do eventually. You don't need to do that right away.
There's also a part of it if you want to make it your career where not only do you have to learn what a cache line is, you have to like care about that and want to learn it and enjoy learning it. Like if that is like pulling teeth to you, you're going to be miserable trying to go like any further in one of these careers.
I don't think you have to learn what a cache line is, or the analogy that we're going for. I don't think you have to.
Like, you don't have to.
Yeah,
I don't know.
Like I said, I think there's this, like we call the senior software engineer like the career level for so many people because that's the level that people stay at for their whole career. And you can stay there and never know what a cache line is and not even care because you're working on problems that the business is giving you and you're a software engineer and you're writing code and you don't care about that stuff. And like, yes, knowing it will make you better and it will, because you're going to understand more about the system and you can make better decisions and blah, blah, blah. But you don't have to know it unless you want to like improve yourself or maybe even improve your career and go to that next level, right? But I think that's true of any profession. You don't have to know how the car is built or how it works to be a good race car driver. But if you want to be the best race car driver, it's probably going to be beneficial for you to understand that tire wear happens like this and the engine operates like that and blah, blah, blah.
I mean, I don't know.
Yeah, it's hard for me to take that perspective because like I just don't know it, right? Like I do want to be the best at what I do, right? And I definitely do like get annoyed at people when they don't take the time to learn these things. So I don't know. I don't know who's right there.
I've worked with a few people over the years that were absolutely 9-to-5ers. They showed up, they did what was asked of them. They were perfectly capable software developers. But at 4:30 every day, they started signing out, and at 5 o'clock, they turned their computer off and went home, and had no interest in, to Matt's point, in diving down further and understanding how operating systems work, or what a queue is, or what the difference between a binary search and a whatever. They just didn't care. They were there to do what. It was a job.
I kind of feel like you're conflating two things there, right? Like you can be a 9-to-5er and not work outside 9 to 5 and still be interested in learning all those new things and like care about them without like doing that as a hobby at home, right? But I bet there's a large overlap. But you see what I'm saying?
Yeah, I think it's like not 9 to 5, like what I was saying last episode. When I was like, it's not 9 to 5 specifically. It's just like a class of people that generally fall into that. But I do want to disagree. That I do think that at some point, if you're going to be a professional person that's going to professionally build software, you need to know how the thing works. Like I think it's like, if you're going to be a doctor, you need to know how the whole body works. Even things outside of your specific area of expertise, you should understand how generally everything works, because it's all interconnected at the end of the day. And like, how much do you use that knowledge? I don't know how much of that knowledge you actually need, but actually having it, I think at the end of the day, like the corpus of knowledge I think software engineers need to be good at software engineering, I think is much, much wider and requires things that are much deeper than what we currently think. That doesn't mean you have to learn it right away, but I do think eventually we need to help people start learning things.
Okay, I can agree with that, and what you said makes sense. I don't think we have to learn it right away, and that's kind of the framing of where I was getting at. Is I don't think you shouldn't like deny yourself going into this industry or any industry really because you're not the best right out the gate and you don't know everything out of the gate. You got to give yourself some grace and time to get there. And I think there's a lot of people out there that say, no, I'm not going to learn software engineering because I'm never going to work for Fang. So what good is it? Well, there's more than Fang to work at. And that's kind of the perspective I was trying to get at is There's room in this field for people. You don't have to just be the top 0.01%. You should strive to get there for sure, but you don't have to be that right out of the gate. And that shouldn't be what like precludes you from coming in.
To that
I'm
point,
not even sure you need to strive to get there. Like I don't think you have to.
So to that point, my career has been a long one. I was probably 12 or 13 years in before I was to the point where my skill set was what I would call a senior engineer. I wasn't one that did hobby projects and dove in and learned all the new languages and aspired to go work at the big companies. It was just a job for a long time, but it was a job that I was interested in and I was good at. And it took having to solve similar problems in 4 or 5 different programming languages in a couple of different industries before, what to Kris's point, to kind of the more general knowledge of how everything fits together for me to kind of make that leap into, it doesn't matter if I'm writing C++ or Java or Python or Go or Rust. The real skill set is the problem solving and the thinking in terms of the logic that's happening and being able to do the analysis of what's going on. And the rest of it is just tools. But it took a long time for me to get there.
Yeah, and I definitely think my perspective on like how much you should learn. I mean, I think the main thing that we're kind of saying here, I think the thing that's important is not, what percentile of you are in the software engineering field. I don't think that really even is a thing. Like I don't think you can really compare people in that way, compare what we do in that way. But I think going back to the thing we said earlier, where it's like curiosity is important. I think the desire to learn is the main thing that needs to be there. And I think if you have the desire to learn, you will eventually stumble your way down to like, oh, how does the CPU actually work? How does the GPU work? What are these things? So I think that that's a very important thing. But I also think for us as an industry, right? If you want to enter this industry, like, do I think that you should enter into this industry if you don't have any interest in learning the lower level things? I would say emphatically no, because right now we have this gigantic problem where it doesn't matter how much better our hardware gets. Software people just squander it. All of it's squandered, right? People are talking about trying to like swap out electricity with light because light is so much faster, so our processors will be faster, so you can have more things in data centers talk to each other more quickly. And it's like, you can't give us another 2 or 3 orders of magnitude in the hardware and not have us waste it unless we actually start understanding why we've wasted everything we've gotten already, right? We've had like so many. I think like we've had like a billion times improvement more than that in our hardware, and our software has not gotten much better. And a lot of that is because software people at the end of the day are writing software that, you know, does the job, solves the problem, but doesn't solve it in a way that like the rest of the ecosystem, I guess it doesn't solve it in a way healthy enough for the rest of the ecosystem.
Well, to some extent, I think software engineering as an industry has kind of ridden the coattails of the hardware improvements. We've stopped having to worry about memory usage because most languages are garbage collected and most machines have multiple gigabytes of RAM. It's not normal to have to do the kind of tricks that John Carmack did to get Doom to run in whatever it was, 600K. Like,
We should put that in the show notes. The Doom inverse square.
yeah,
We're
like
talking about. It's really cool. We'll put it in the
software
show notes.
engineering used to be these feats of logic to find ways to do things that other people couldn't figure out. Whereas in the 90s into the 2000s, it became much more of a mundane task in general because the hardware just propped us up.
Yeah.
Yeah, this is true. And real quick, I like your point about like not comparing people, Kris. And it reminded me of like the thing you said earlier where like the person didn't know how to install the hard drive. And you take those two people. Is one better than the other strictly? No, right? Like they have different skills in their different areas and they both are great at what they do, but they're focused on different things. So that this whole software field is filled with that nuance where it's like Kris might be the best Go programmer on the planet and Matt might be the best PHP programmer on the planet or something. Does that mean Kris is strictly better than Matt or Matt is strictly better than Kris? Like, no, there's nuance in there that we have to figure out. And to the point we're making about hardware kind of like gathering us along as software engineers, I think the industry used to have the constraints like forced upon them. And so they were there present when they were building software. And now constraints are like not really thought of when you're programming or writing software. You just kind of focus only on the problem with almost no constraints nowadays in like the average case.
Yeah, I think that, I mean, one of the things also popped into my head, right, is like, how much do software people, you know, even maybe everybody in this podcast right now, understand about networking, right? I think a lot of us are like, most of the time, we don't need to care about networking, right? But that has
We got some head nods yes, some head nods no for the listener.
that has caused like some like very big problems with lower level parts of how everything works because even we don't really understand it. Like a good example is like Ethernet, right? Like I've been thinking about this way too much lately for reasons. But like Ethernet, when it was created, you know, you had 10 megabit Ethernet, you had this frame size of 1500 bytes, which is like 12,000 bits, which meant that, you know, to have a line rate of 10 megabits, you had to process 800 packets per second, right? We're not at 10 megabits anymore. We're at, you know, 100 gigabit, right? You can have 100 gigabit now. But we never changed that frame size. So now the hardware, instead of having to process 800 packets per second, it has to process, what is that, like 8 million packets per second? And that is a completely different scale of thing. So it's like, oh, if we wanted to get that 100 gigabit Ethernet going, then now we have to actually build custom hardware. And now your NIC has to be its own little computer to actually be able to process things at that LAN rate. And now we've made the entire thing more complex. And like, why is it complex? Because we never bumped up the size of Ethernet frames. If we just made Ethernet frames bigger as we were going along, if we just said you should have to process about 1,000 of them per second, our CPUs would still be able to handle that. And we probably wouldn't need all of this extra complexity that makes our entire infrastructure, all of the systems, everything involved in building software and building hardware and making computers much more complex. We wouldn't have to do that if we'd actually said, okay, well, we need to push these things forward. But the problem is, who's going to be arguing for that, right? If you had all the software people saying, no, I want to be able to take advantage of bigger packet sizes in IP or in UDP. Like I want a 4 meg packet, because then I can put so much more in a single thing, and I don't have to think about things as much. But because not enough of us dig down into that layer, not enough of us understand that layer, there's not enough of us to create pressure to actually fix these things in the places they need to get fixed. So we, as an entire all of humanity, winds up suffering. Like, the way that the internet is coupled together and continues to be coupled together because of these small things that not enough people know is like really problematic. And I think that part of what we need to do as professional people is understand that we might have our area where we care about things a lot and understand things a lot, but we also need to care about all of the other things, because we have to form the collective of people that is saying that thing right there has been neglected and we got to go fix it. And even if I'm not directly, writing Ethernet implementations, or I'm not writing operating system implementations, I'm going to go talk to the people that are and say, this is something we need to prioritize because this is going to be a problem in the future. Like,
a similar story. A few years ago, I was tasked with what was essentially upload this directory to an S3 bucket. It was great at doing concurrency. So we did a semaphore with some gating and go routines, and using the IO package to go just IO copy this file to that network socket, and it was great until we brought down other production systems because we had saturated their network uplink, and they started getting hardware failures.
Right.
The to both of your points, the hyperscalers of the world, or the ISPs of the world, they think about some of these problems, and they do this, right? They have jumbo frames enabled, or their own custom, stack there, layer 2, whatever. And it's funny because you're not wrong. We could get away from that archaic constraint, possibly. I don't know what all the ramifications are there, but we could reevaluate that. Because if you think about how traffic flows across the network, like my device talking to my router on 1500 MTU, but then once it gets to my ISP, maybe they're bumped up to a higher MTU. Maybe they're using their own. Maybe they're not even using Ethernet anymore to relay that information to one another. Who knows? And it's that sounds good on paper, because it's oh, the internet is just so redundant and we just have all this cool thing. It just works. But we're not thinking about the other side of that costs more CPU time or power to do that, or we're doing translations basically at every hop almost in the network. And is that efficient? No. Is it resilient? Yes. So I feel we've tipped way too in the realm of resiliency, and we can probably circle back to efficiency a little bit.
Yeah, I mean, I think it's interesting how some of this has to do with finances, right? The reason why we can't increase the MTU of the internet as a whole is because you have to increase it across all of this. And there's just these very old boxes that have a 1500 by MTU, and you got to convince that ISP or whoever to upgrade that box to something that can be, bigger. So the way you fix this problem is you got to do it over time. You got to increase all of these things as you go, not do it once every 60 years. It's with the New York City subway, right? Where everybody's we dumped billions of dollars into this thing. It's yeah, we spent 70 years dumping nothing into it. And now we got to play all the catch up with that. And that's how a lot of the networking world works. You got to play a lot of catch up. Another good example of this is with the Quick protocol, right? Quick.
Whoa. This was a very long networking tangent for
one more thing. Okay, one more thing. One moment.
See what happens when we let Kris talk. This is what happens.
Certain aspect of this, where with Quick, they have done 2 things so far. They've already revved the version of it, and they have also added this little bit in the protocol that just kind of flips randomly as you're sending things. And that's because they found out that there were boxes that just basically had protocol images baked into them, and it just kind of ossified the whole thing. And that's why TCP can't evolve forward. So it's as time goes on, they figured out that we have to continually change things, continually be updating things. And that is how we stop everything from ossifying. And I think that's, and that involves all of us. We all have to create that pressure to stop things from ossifying, because if you don't, it's too small a group of people for us as an industry to care enough to invest the effort to make those things not get stuck. And then that winds up affecting all of us.
So to close the loop,
I was going to kick him off the tangent anyway, but you got it.
To close the loop, okay. To close the loop, should you learn to code? Yes. Should you become a software engineer? Did your eyes glaze over while Kris was talking about networking protocols?
I mean, that is a good pulse check for it. If that was boring to you and you were like, I don't care about any of this, that's probably a good sign that maybe you're not so interested in the field as a whole. Maybe.
If you opened Wikipedia and started looking at these protocols, maybe think about.
Yeah. Even if you're not
open
working
that Python.
on, even if you're not building network hardware, like those are the kinds of problems that come up in software engineering. Like, how do I solve this thing given external constraints that I can't control? 1500 MTU, amount of RAM, all these things that are kind of, to me, it's always been the engineering side. Like, I have fixed constraints. How do I fit the pieces together to solve the problem? And to me, that's the difference, or the hill to climb between coding and kind of, to what Matthew was saying, to go make a computer do something that you need it to do, versus software engineering as a career of, do you find joy in solving those kinds of problems and picking them apart and turning over the rocks and figuring those kinds of things out?
Yeah, I think I would say on that as well. I think there's this idea that a lot of people have that, like, just because I was talking about networking, like maybe you don't actually need to know this early on. And I think the moment that you're designing software, which I think people should really, I think like as an industry, we need to have people designing software much earlier in their careers. I think not knowing these things leads to poor designs that can very quickly become industry standards, right? Like if you look at, how we do networking, basically across the board now with microservices, a lot of it is based on things like gRPC. And you have to ask the question of like, is this really the design we want to have, right? Have we actually understood the context we exist in? Did we have enough knowledge when we did it with like how Kubernetes works and how these things work? It's like in the historical path we took, I think a lot of these things do wind up making sense. But since people didn't have the underlying information when these things were created, or for whatever reason didn't include that underlying information when they created, we wound up creating things that aren't as good as they need to be. And they cause a lot of either resource waste, or they make systems that don't work, or systems that have a lot of bugs. And then those bugs bubble up into affect real people's lives at the end of the day. And it makes their lives hard. It makes people that don't have anything to do with, your company and what you're doing, now they have to suffer the consequences for it. So I think to that question of like, do I think people should code? I think like if you want to build even hobby software, like if you want to be someone that builds software that you give to other people, I think the answer to that is like, are you ready to potentially have the responsibility of you being a load-bearing member of society? I think that's a very important thing that people need to understand, because if you make a little hobby project, it could turn into Log4j, it could turn into BoltDB, it could turn into SQLite, it could turn into one of these things.
The
that
XC
is just
problem,
everywhere and ubiquitous.
Mandatory XKCD cartoon reference.
Yeah, you could be the one in Nebraska maintaining ImageMagick, right? You could be the guy that maintains curl that is used literally everywhere and everything, and you put one mistake, you make one bug, and that could crash the world's infrastructure, right? Like, I think everybody needs to recognize that if you're going to be someone that gives software to other people, if that's the line you want to cross, you just have to be prepared that might happen to you. It might not. It doesn't happen to a lot of people.
Okay.
But it could.
Full disclosure, if I would have gotten that speech in 1996, I would not be here today writing software, because that's a lot of pressure.
It is a lot of pressure.
That's actually an interesting point, because like we've all been in this career for a while, and I actually think the bar is a lot higher now than when we started.
In what way? Like, what way do you think?
I think specifically like breaking in is a lot harder. Like all four of us, or 3 out of the 4 of us, said we fell into these computer science jobs, right? That's not happening anymore, right? Like, like
this
people,
is true.
it is competitive out there. And so I guess the point I'm getting at is the bar is higher, so you're gonna have to want it more. And if you don't enjoy it, you're not gonna want it more. So like my my answer to should you make it a career isn't just can you do it, like, but do you want to do it, right?
Yeah.
Yeah.
I will
And
caveat what I
that's
just said as well. If anybody is a little scared now after hearing what I just said, of like, you don't have to become a load bearing part of society. You can choose to not to. You just have to make it. You have to be very explicit that that is not what you want to do.
correct.
And I want to warn people too, because it's very easy to accidentally fall into it and then get stuck. So if you don't know that this can happen and all of a sudden you're like, oh, I have this popular library. This is great. I have all this fame. People are telling me how great it is that I'm doing this thing. You can easily get stuck if you're not careful. So I just want to like,
And not even just public things. Like I worked as on a team that supported like HR and recruiting and kind of all the internal teams at a company. And you end up over 5 years you build them 30 different tools, and all of a sudden the maintenance on those 30 tools is a full-time job, and you no longer have time to build new things, right? So that trap isn't just in the public, it's everywhere. Like you
Yeah.
become a kind of a linchpin in a lot of organizations. Like they're depending on the things that you built to do their jobs.
For me, the difference in the environment is pretty striking. When I started, open source essentially wasn't a thing.
yeah.
Almost all software was proprietary corporate software, that you were writing something that was an internal system for the company that you work for, and no one else is ever going to use it. Compared to today, pretty much everything goes to GitHub by default.
Yeah. You're not
People
wrong.
that are learning to code are creating a GitHub account and pushing their code out, and or contributing to existing things that are out there. So everything is out there and available for other people to use. So there's a lot higher potential of someone else pulling in your thing and depending on it than there was when I got my start.
Yeah.
I'm glad that Kris didn't say anything that was going to make me change my opinion of what he said, because I agree. I agree with what you said. Like the scary story, like this. If I would have heard this before, I wouldn't be here. Like I agree with telling people these things, because a lot of things are out there in life where people don't know what they're getting into. And I like the fact that you outlined these are potential things that you can get into. Be aware. Don't be afraid, but just be aware that this can happen, and like do what you can, to adjust to that or avoid it or whatever you want to do. And like you mentioned, like ossification in terms of our like network devices over time and whatnot. But there also is that same concept of to us as engineers or as programmers or as whatever title you want to give us. If you are just going to come into the field or learn to code and only just do one thing forever, that's going to be a problem. You're going to be left behind, so to speak. You should encourage yourself to try different tools or different paradigms or whatever, or even just different industries of applying those skills. And that's going to make you a better, well-rounded program. And it's actually going to increase your curiosity of like liking things and seeing what you want to do.
Yeah.
So that's kind of my thing.
Like continual learning is, I think that is something that I want everybody that wants to do this professionally, like just continually learning, continually growing. I think it's kind of like how I don't remember where I read it, but there's this thing with doctors where a lot of doctors just don't continue learning once they graduate med school. Once they do their residency, now they're in the field, they're not learning nearly as much. And when you kind of say it to people as like, yeah, do you want someone that has like the most current knowledge or someone that has knowledge from 30 years ago? You'd be like, okay, I would like the most current knowledge, please. I think that's the same with like, I mean, it's hard to do that in law because law is always moving. But I think like that's the same for us of like, yeah, you got to keep refreshing your skills. You got to keep learning. You got to keep growing. Like if you're someone that finds change to be extremely stressful, I'm not saying don't become a software engineer, but just make sure that you're ready to push back against that a bit. Because I think there are currently I've run into too many people in my career who learned, were learning a lot when they were younger, and now they're deep in their career and they don't really want to learn as much, and they've become like the fossils of the company, where it's just like, okay, we got to find a way to work around this person because they don't want to learn something new, or they have really outdated knowledge, and you have to like spend all this time like educating them and telling them, and it drags everybody else down. And I think that could have been mitigated if it was just like, no, just have a little bit of time to learn some more, do a little bit more learning. If someone had told them that in the beginning, or if people were just told that in general, I think it would help some.
Yeah, I agree with that. It's something that I literally just wrote a blog post like 2 days ago talking about like changing your tools, right, in the new year. And that's something I mentioned of like, you should be encouraged to change your tools or to change your skills or whatever. Just give it a shot and see where it leads you and see how it makes you think about these things. But so many people are so ingrained into the programming language they use. They never go to another programming language or the editor or the OS or this. And it's like, you're doing yourself a disservice. I'm not saying change your editor every 2 months or whatever. That's not what I'm saying. But every once in a while, if you're going to be digging those holes, right, learning about with your backhoe or your shovel, you should come up once in a while and be like, what else is new in this industry? Is there a new type of backhoe? Is there a new type of shovel? Is the act of digging holes been like replaced? You should be challenging yourself and doing that every so often, in my opinion.
Yeah. I think that also helps answer another question that I think most people probably have, that I definitely got asked when I started my career. Is they're just like, and I started my career like almost 13 plus years ago, is like, oh, isn't all of that being automated away? Isn't AI going to just replace the need for programmers and for people writing code and all of that? And I just want to emphatically say right here, right now, no. AI is not going to replace people writing code.
Louder for those in the back, please.
I'll say that again. AI is not going to replace the need for people writing code. It might change how we write code and what code we write, but it will not replace the need for people to write code.
I will say, I was talking about that bar being higher now, and I do think the introduction of AI does make finding like a entry-level position harder. Not because like AI can replace those entry-level people, but I think you said this earlier, Kris, or maybe Matt, that like there's a lot of companies spending a lot of money to advertise to tell those managers that it can, right? So I don't know. I do think it's, if you do decide that you want to make this your professional career, it's not going to be an easy path for the beginning.
Yeah, I guess I'll say I've played with AI enough and LLMs to have ridden some of the hallucination tangents. And just, yes, it's not there yet. It's very cool and it's does some interesting things, but at the end of the day, it's still just a statistical word generator. And it will lie to you with a straight face and never hesitate.
Yeah, it'll give you the right equation with everything plugged in right and then the wrong answer.
Sounds about right.
I mean, this happened to me the other day. I was Googling because I needed to, doing that project I was doing with CSVs, I needed to like reverse. I was trying to figure out, is there an easy way to just reverse a CSV in like, in Bash? And I looked it up, and then Google gave me this little AI review thing. And it was, oh yes, you can use the tac command for this and blah, blah. And I just do this. And I went in, I literally went to my editor. I was like, I've never heard of tac. I typed tac in, wasn't found. And I was about to keep going and looking for how to install it. And then I was like, that's cat spelled backwards. I was like, oh, you're really annoying.
You know that it like probably inferred that because of if and fee and case and ESAG and all of the bashisms that are out there. So it's probably like, wait a minute. If I can do cat for the forward, I could do tac for the backward, right?
Yeah.
Yeah.
I was so annoyed in that moment. I was like, and then I went and wrote a bunch of Go because I'm like, I know I can do this in Go. I'm not going to try to do this in Bash anymore. So yeah, those, even the best of us, those hallucinations will just like, make you question yourself a little bit of like, oh, maybe like, no, like tac does not exist.
Those have always been my kind of points of hesitation because it's really good at spitting out something that sounds plausible. So to me, you almost spend as much time verifying what the AI told you as you would have just doing it yourself.
Yeah, I agree. I mean, it straight up lied to me about OpenTelemetry configuration. I was like, hey, how do you do like a filter here in OpenTelemetry? And it gave me configuration that was just not valid. Like plugins that didn't exist, all of that stuff. And I was like, oh, you don't know, do you? You don't know anything. You're just guessing. At least when I talk to like an experienced engineer or something, they're going to tell me they don't know, and they're going to say, I don't actually know the answer. Sorry. They're not going to lie to me.
Or even
AI
some random
likes to lie to me.
Even some random person on Stack Overflow replying to your question.
Yeah.
They're at least like took a shot at it. And was
Right.
Like,
That's not to say that I don't like AI though. I use it all the time. It's like having, like we're all here, we're talking on the podcast. It's great. We're sharing perspectives. When we leave, I don't talk to you until like, we do the next one or we talk in back channels. But like, I can't just easily say, hey, Kris, oh, that quick thing you're talking about, can we talk about it more? Like, it's a little harder because our schedules have to align.
Right.
But with AI, I can just be like, open it up. You're an expert in networking. Talk to me about quick. Give me the TLDR. And that's super helpful for my workflows. It's like, if I had this when I was learning, like by reading books mostly, it would have supercharged my learning. I would have been talking with AI all the time of like just that curiosity itch that got me into software. AI can help scratch that really, really nicely. And that's what I like about using it. Do I use it to write code? No, I'll use it to like sketch out things, but I won't use this to actually write my code for me.
Yeah, I think it's, I've been thinking a lot about this because I think also it's the same as with Wikipedia, where if it's something that is very well known, very well understood, that a lot of people have talked about or written about, it gives you very good answers. Like AI will do this, Wikipedia will do this, Stack Overflow will do this. But as soon as you start getting to the edges, those things that may be a little bit controversial, or those things where like people just haven't had the right perspective on them. Like now that I've been digging in and trying to like learn about how computers work and more about distributed systems and networking and all of this, there's a lot of wrong or missing information there. And I think that's the area where AI does terribly. And I think even Stack Overflow does bad at it. Wikipedia does bad on it. Like an example, quick little example. I've been, going down YouTube rabbit holes about networking lately. And I've always wondered, like, you have these three devices, a bridge, a switch, and a router. And I've always been so confused about what the difference between all of these devices are. And through watching these videos and now reading a book by literally one of the people who helped create the idea of routing in the first place. Like she wrote this book and she's basically like, yeah, no, these words, we're just kind of trying to make up new words. She's like, I kind of understand why we have them, but no, like there's not a lot of difference here. Like the difference between a switch and a bridge is basically null. You have like bridges and routers, and then you have these things called switches that sit between. And it was like the first time where I had it explained to me in a way where it was like, oh, I'm not crazy. I'm not the dumb one sitting here being like, none of this makes sense, with people giving like very strong definitive answers about this is a bridge and this is a switch and this is a router and they are very three separate things. It's like, no, this is all a mess. This is all very muddled. And I think that's one of the things that trips, I think, new people up sometimes with the esoteric knowledge, but also very experienced people with the esoteric knowledge.
In AI's defense, I have several times over the course of my career done a Google search and got less than 1 page of results where 5 of the 6 answers were links to the first one. And I definitely have channeled Denver Coder 9 from the XKCD cartoon quite a few times. Like, this is a thing. I'm quoting the error message from this Windows component. How is no one else on the planet experiencing this?
I've thought about this too, because I've had the same thing, and this is one of the reasons why I'm starting like to write more, and I want to write more and get more content out there. Yes, I know AI trains for free off of my content, blah blah. I get all that, I really do, but also humans are on the other side of that content too, and I don't want humans to like end up like you did, where you look for something, you're like, none of these are helpful. I'm stuck. What's going on? So that's part of the motivation of why I like to create and write and whatnot, to like help counteract some of that stuff.
Yeah. I think if, you listener or viewer, do decide after all of this that you want to become a coder, I think something that you should do is blog. Like if you run into a problem, write a little bit. It doesn't have to be like a blog. It could be on Blue Sky. It could be on Medium. It could be wherever you can throw some words, but hey, I ran into this problem and here's a solution I found that works for me. Just share what you learn. I think it's a very important thing that I think not enough people do, because they think they're too early or too inexperienced, or they haven't done it. Or, no matter what level of coding you do, even if it's just Excel stuff, even if it's, whatever it is, when you decide you want to do some coding, put that information out there into the world. Yes, it does help AI models get better, but I mean, we're going to be stuck with these things for a while anyway. I would prefer them to be a little bit better at not hallucinating things in any way.
Let's give them some better inputs.
And for when ultimately all of this AI stuff collapses and falls into the ocean, the stuff you published will still be out there for people to consume and to have. So I think it's important to do that. Don't just hold stuff in your head. I've definitely been guilty of not doing enough writing, and I think we should all be doing more writing, because then when you do that Google search like Dylan did, you won't have 5 results. Maybe you'll have 50.
Totally agree. And it helps exercise those muscles of thinking through a problem and formulating your thoughts better. So even if you're like, oh, nobody's going to read my post, you're going to write it, you're going to read it, and that's going to help you think about the problem better.
Yeah,
and
just
that's
the act of explaining it will, kind of like Matt said, that will exercise the muscles of breaking it down into the parts and organizing them and thinking about them in a structured manner. And that is, at the end of the day, what we do.
Yeah, totally agree.
All right. So we've been on this long journey. And so I think it's time to go to the last segment. But also, if you're wondering, are we going to answer the question, should you learn to code? I don't think there's a definitive yes or no to that. I think you got to go back and re-listen to everything we just said, and then decide for yourself. I'm not going to give you a yes or no answer.
As with all things, it depends.
It depends. That's the best way to end this.
Should we tee up the next episode?
Yes. Coming soon to your ears and eyes is part 2 of this wonderful thing. So this one was about, do we think you should learn to code? The next part is going to be all about, should you get a career in this? Should you build a career in this? And we are going to have a very special guest. He's a recruiter that has been in this industry, been doing tech recruiting since the 90s. So he's seen the .com boom, the Great Recession, everything that happened in the 2010s. He's seen all of it. So he'll be joining us to give us a perspective of, what's it like to get a career in tech? What are the things we need to know? And we'll all be here to give some commentary around that. So we're
see if he agrees with what we said.
Yeah, well, we shall see.
So
Which
true.
you might not.
Yeah, I mean, he might not agree. He might agree. The listeners out there, you might agree with him. You might not agree with him, but we're super excited for that. And now, let's do some unpops. Who's got an unpop? Anybody got unpops?
I have one.
Okay.
All right. My unpopular opinion is that muscle memory is not immutable. It can be changed. It can be overwritten. It can be modified. I think a lot of people spend too much time saying, oh, I have muscle memory for this. That's why I can never try something new. Yes, you can. You can mutate muscle memory. It just takes some discipline and some training, but you can do it. And don't use that as an excuse. That is my unpopular opinion.
Sometimes you have to slow down before you can speed up.
Are you secretly telling me I need to learn Emacs? Because if you are, I'm gonna say no.
I have
but that's where I hear it a lot too. I already know my Vim bindings. Okay, great. But there's other things.
It's really funny you bring that up because I have just started my Vim journey. That's
congratulations, and I'm sorry.
There's a terminal session somewhere that's still running a Vim instance that I can never get out of.
Try getting out of Emacs. I really makes fun of getting out of Vim, but getting out of Emacs. Anyway, well, Ian, welcome to the Vim journey. You can escape until you learn the power of macros, and then you're just stuck in actual Vim for forever because
oh yeah,
all those key bindings, great until you want to make a macro out of them, and then things start to fall apart when those
I'm not quite there yet, but we'll see.
Okay,
I look forward to your muscle memory being developed.
that's a whole new way to think. All right, I like that one. I feel like I agree with it that muscle memory is a very mutable thing. It's a thing that you can develop and change over time. See, I do think people ossify themselves sometimes. They're like, oh, no,
100%.
I don't want to change. People are very change averse.
I look at cars. Like, we used to have manual cars where you have to like actually row the gears, which I still have one. They made automatic cars where the stick's in the middle and you like select gears. Now, like, modern cars have it where the windshield wiper is, like on the stick of a steering wheel. It's like, if you made the argument of muscle memory, then by definition, then go back to driving a manual car. if that's so important to you, like, go back and do that. Don't learn anything new ever.
Although in some ways we've come full circle because manual cars used to have the shifter where the windshield wiper thing is.
Yeah, this is true. I remember that.
All the way around.
But yeah, so I just want to encourage people to, like, don't use that as an excuse. Give it a go.
I like that. I like that one. Anybody else have an unpopular opinion? I feel like Dylan always got unpopular opinions.
I did not come prepared this week.
Okay. I feel like Ian's contemplating. He's thinking.
Yeah, Ian's pulling one right now. I see it.
It's slipping away. I don't know if I have one. All right, I got one. This is
yes.
Okay.
This is not a good one, but I don't think anyone needs an iPad. No one needs an iPad. No one should probably even have one. Like, it is the most.
You say that's not a good one, but that's actually a good one. For the definition of unpop.
Silliest device that's ever been made. Like, I guess if you only have an iPad, right? But like,
I can
if you have
hear
a phone
and feel
and a computer,
our like future listeners cringing at this right now. I feel it.
As a corollary to that one, I guess I'll throw my own as a corollary. An iPad is not sufficient for a software development machine.
It's not sufficient for anything.
Not if you don't have a server somewhere else.
I know a few people who've done it. They're like, oh, it's great. All I have is my iPad and a Bluetooth keyboard, and it's wonderful. And I'm like, no, it's not.
I have seen people connecting their Mac Minis to their iPads, though, and that kind of seems slick.
Oh, that's cool.
Why don't you like the iPad? Like, what's wrong with it?
I just think it's the most superfluous device that's ever been made. Because everyone has a phone, right? And you can do everything on a phone you can do on an iPad, unless you're an artist, right? If you need the pencil and you need to draw, right? But then almost everyone also has a computer. And so it's this weird in-between device that like you use to, it's like a $1,200 YouTube machine, Like,
let's be real.
Or kid babysitter.
In 3 years, the iPad 18 Pro Max Plus will actually be a 10.5-inch iPad.
Not wrong.
I mean, the iPad Mini and like the Max iPhone are pretty. You can actually put the iPad Mini in your pants pocket. Well, in men's pants pockets. Women's pants pockets don't exist. Yeah. But like you can literally like I've put an iPad Mini. They don't. Have you like they?
No, they totally don't exist.
Like you could literally fit an iPad Mini like in your pants pocket. But I would say, for the vast majority of people, iPads are a weird thing. I think you did point out artists, I think, are one thing. But I think businesses, like I think the whole replacing your point of sale terminal with like an iPad is like one of the most beautiful things that have ever happened.
Oh yeah, I can get down with that. That's a great use for an iPad.
Like that is chef's kiss, beautiful, amazing. That's how it should have always
we do that
been.
in the chocolate shop. It's pretty worth it.
We also
but we don't
have
use it
an
for
iPad.
anything else. Like just that.
We do have like an older iPad that we have that runs all the lights and stuff in our house. So when we have like a dog sitter or someone staying over, they can still control the house, and that works pretty well.
Yeah, it's very like esoteric advice.
That's the most first world iPad usage in the that's ever existed. So
yeah,
I'm still a Luddite. My most fanciest home gadget is the keypad lock on the front door.
I don't have one of those.
Neither do I. I carry keys.
Yeah,
that one freaks me out actually a little bit.
Yeah.
Have you seen the video where the guy just yells to the door, like, hey, blah blah blah, unlock the front door, and it unlocks the
Oh
front
yeah,
door.
I've seen that.
Absolutely.
I've done that to people. Like I've done the Hey Google or Hey Siri to people on calls where they're on speaker. Like Hey Google, and it's like yes.
no.
You can also just like shine a laser at those and have it play a pre-recorded message so you can like get them through the windows. The locks on smart locks, don't recommend. That can be another unpopular opinion. No,
Yeah,
say
no,
no
thank
to
you.
smart locks.
We have two different Jeeps, and the Jeep is the voice activation keyword, and it's very, very sensitive. Anything that sounds remotely close to Jeep in my car is like, what would you like to do? Leave me alone, robot.
No, absolutely not. Talking things, like I'm so mad the number of microphones are shoving in things. I'm like, I want the option without the microphone. I don't want a microphone in my TV. I don't want a microphone in my sound bar. I don't want a microphone. Like, just get them out of my apartment. Do not want.
And it's kind of slick
the
though because they
Sonos-
use them for noise canceling. So there's always mics now in a lot of speakers.
Well, yes, that's like different though. I just want a mic. I don't want a mic that's hooked up to the internet. That's what I.
Yeah, fair.
That's
I
what
just want my Sonos app to stop being like, hey, do you want to use our assistant? No, I don't.
I just want the Sonos app to not suck anymore. That's what I want.
Like,
I just
Good
want
luck
you to
with that.
play music.
Oh no, I was thinking about getting a Sonos. Oh no.
I love the Sonos, but
The app is just. I mean, there was a message in it from the CEO that was like, very sorry about how garbage this app is. We're gonna do better in the
I
future.
remember that.
Honestly, I can respect that because that's a good way to communicate to your customers. Like we know we're
It
sorry.
is bad. It is. It's a little bit.
it's
better.
gotten better.
very
It's
bad.
gotten better.
Yeah. Okay. My unpopular opinion. I've been watching something lately. Some video I was watching about AI, where it was just like, we've just meshed too many things together when it comes to AI, and they're actually separate things, and we need to like pull them apart from each other in our minds. So I'm just like, we need to stop using the word AI. That's my unpopular opinion. Like, we just need to stop. Call the things what they are. If you want to talk about generative, intelligence things, go talk about those. If you want to talk about autonomous vehicles, go talk about those. If you want to talk about machine learning, go talk about that. But don't like intermix all of these different things, because it's confusing people. People look and they're like, oh, we can make all of these cool images and videos and all of this like text and chatbots. We're so close to being able to do whatever this other completely unrelated part of AI is. It's like, no, those are not the same areas. Advancements in one area will not help other things in other areas, at least not directly in the way people are thinking. So I'm just like, dispense with the word AI, please. Just like stop using it as an all-encompassing bucket.
I would agree with that one. Like
So go ahead. Go for it.
I hate that like to the general public, AI is now LLMs and like generative imaging. Like, because then when you like say like, I don't know, I actually think like ML like applications and optimizations there is to me a lot more interesting. So it's, I don't know, it's like it just annoys me, I guess.
Yeah.
I was just going to say what you refer to as AI is actually AIML. Okay. Excuse me, sir. I had to make the joke.
I'm an 80s kid. I just want the Night Industries 2000 that could drive itself and talk to me with ejector seats.
Weren't we supposed to have hoverboards 10 years ago now at this point? I don't even
And
know.
flying cars? Oh,
Yeah.
dude, I don't want to think about the disaster that flying cars would be. People can't drive cars on a 2D plane correctly. 3D? No, thank you.
Yes,
No, thank
it
you.
would be
Oh,
terrible.
yeah.
I don't know. It's just one AI thing. I am looking forward to the day where I can just like ask my phone like, hey, what time did Kris say our dinner next week is? And it gives me the right answer. Like,
I mean,
that will be
supposedly, Apple Intelligence.
I don't believe it.
If we could actually get Jarvis AI like useful, like you said, hey, when was that thing? And it gives you accurate answers.
Yeah.
One day.
Yeah, not
one
this
day.
weird where I give it a picture of someone and it comes up with this monstrous cartoon version of it. I don't know if you guys have messed with the Apple intelligence stuff, but it is not good.
I haven't. I've tried to disable all the things so far, but, such is life.
Is there a helicopter outside your house?
Yes.
Okay. Just wanted to make sure I wasn't going crazy.
At first I thought it was one of those like pavement pounders,
Hey, we've done well because when before we started, there was someone across the street running a chainsaw, and we didn't get much chainsawed, but now we get the helicopter flyover.
Yeah, that's good.
Interesting.
All good.
What are they looking for in the swamp? Who knows?
I don't know, gators.
Drones, the Jersey drones.
Oh God, the Jersey drones. Anyway, before we get on another tangent, let's wrap this up. Once again, thank you, listener/viewer, for hearing us ramble for a bit. Yeah, and catch us in the next episode. If you wonder, what is our publishing schedule? We have one now. We're publishing Mondays at 8 a.m. Eastern. So prepare yourself every Monday. When you're getting up in the morning, you're like, I gotta go commute, but I get to listen to a fall through on my commute. So that's a positive. Your Mondays just got better because of us.
If you are of a mind for live interaction, there is a fall through channel on the Go for Slack organization, and we do hang out there.
Yes, we are in there. We talk, and of course, we're on all of the socials. Please follow. Please, repost, interact with our posts there. And until next time, have a good day. I don't know how to end it. I don't know what's a good ending, guys.
Peace out.
Bye.
Peace out. Bye. Fall through. Oh God, we need a slogan. Anyway,
Deuces.
goodbye, friends. Goodbye.
Bye, everyone.
Holy God. That does my light again.
It's okay. We'll figure out a slogan.